Number 23. Two streams of water flow through the U-shaped tube shown. The tube on the left has a cross-sectional area A, and the speed of the water flowing through it is V. The tube on the right has cross-sectional area A prime equals 1/2 the cross-sectional area of the left U-tube. If the net force on the tube assembly is 0, what must be the speed V prime of the water flowing through the tube on the right? So we like to know the V prime here. At what rate should the water flow through this right side of the U-tube so that the net force in the x direction in the net equal to 0. To demonstrate that, I'm gonna first start out with the unit, given unit. So earlier it said we have cross-sectional area here, but then the cross-sectional area on the right side of the U-tube is 1/2 A, and then we have V flowing right here, and then V prime. So we don't have equal speed of water flowing, and okay, and I can demonstrate this by writing the unit. So area of the cross-sectional area is gonna have SI unit of m squared, the meter squared, times the V, our speed of water. So we're gonna have meter per second, and that gives us the meter cube per second. So that's the volume flow here, volume flow rate. Now when you also multiply this by density, so kilogram per meter cube, notice it's a mass per volume, you're gonna get the mass flow rate. So meter cube cancel out, giving me kilogram per second. Now if I also multiply this by the velocity again, you will notice that meter per second is multiplied to our mass flow rate, kilogram per second. And then what you notice is we have mass and volume. So if you know the momentum is equal to P equals mv, we have the change in momentum delta P over, so delta P really stands for this, and then we have second on the bottom, so I'm gonna write this as delta T. Why did I write this? Well, now you can see the relationship between the force net and the change in momentum over time. What happened is, okay, we have a force equal as T approaches 0, delta P over delta T, that just becomes dP over dt in calculus. So now you can see that all this equation that we multiplied, or the components in this equation that we multiplied, is relevant to our force calculation. So A times V squared rho is going to be used in both equations, and you will see this is a right side movement in the left side U-tube, and then the right side U-tube has the left side movement, and they will cancel out to be net x direction of force to be 0. So when I write down force of x net on the left side U-tube, we have A v squared rho minus, from the right side of the U-tube, we have 1/2 cross-sectional area, and then v prime and the rho. It's same order, so they will cancel out. The rows will cancel out. So this becomes a v squared rho equals 1/2 a v prime rho. So notice the rho cancel out as I said before, and the cross-sectional area will cancel out. So ultimately we get v prime. So we forgot the square here, by the way, that's important. Okay, so v prime squared equal, okay, don't forget 1/2 in front, and then we have v squared here, and when you multiply both sides by 2, we get v prime squared equal 2v squared. All we have to do is square root both sides. So our answer is ultimately radical 2v. This is our answer. So looking at our choice, C is our final answer.